with us today is Donald Harper. Donald is a field applications engineer with Amphenol Communication Solutions Server and Storage I/O business unit. Thank you for joining us, Donald.
Well, thank you for joining this Amphenol webinar. Today's topic, we're going to talk about what are the trends that we're seeing for Gen 6 solutions, and really what does the future look like for a specific application, which is 8639 U.2 connector form factor. And I want to talk about that specifically and what place it's going to have in these next couple of years, and maybe look back at what the U.2 connector has, how it's been used in the past, and what its history is. And so we're going to talk about trends, new things, what's going on in the new AI world. And this slide is getting kind of old, but it really represents the general picture of what's going on, the huge amount of growth that's taking place in the server and storage marketplace. And it's all driven by this AI information and the AI systems that are being developed. And so it's just exploding. And the last year was a lot of building the first systems and working with our partners to implement their first AI systems. And that pretty much all rolled out in a PCIe Gen 5 speeds. And the next generation stuff has been in the works. It's on the books, and so people are starting to look to upgrading. And certainly the people who are on the cutting edge are the compute customers. People are doing all the compute processing. The AI systems, they're demanding the fastest memory, the fastest compute, the fastest speeds possible. And so that's one of the things that's driving this. And then the compute side is generating all this information and it's getting stored somewhere. And that's what these data centers basically are. A data center is like a large warehouse with hard drives full of storage capacity. And as you know, there's other challenges associated with that. But what's inside that data center is where I want to go and talk about today. And specifically, what does the future look like? And so one of the ways that we look at that is through an organization called the SNIA. This is a server and storage organization that kind of lays out a roadmap for the industry, and they create the standard through the SFF form factors for a lot of these things. What they are showing is that this is their roadmap, and they're showing what kind of connector form factors are going to be needed when. And so as you can see in this chart, there's the U.2 SSD drive has been implemented in Gen 5, and there's been this question, will the marketplace, will the customers want to extend it into Gen 6? And the answer is yes. So we are hearing from our customers saying, we believe this makes sense. We want to build on the backwards compatibility. We want to build on all the hardware that's already in the system. We want to use this form factor for some future generations. So Amphenol has moved forward with that through the standards organizations by presenting some of our performance. And we've taken a pretty radical step of, without customers paying for this yet, we have tooled up our U.2 Gen 6 product line. And we have samples available and want to show you that because we see on this chart, and we know from working with our customers that products are being developed for this specific application, which we call U.2. It's the U.2 form factor, and I want to kind of show you what that is so it makes a lot of sense. And we're pretty confident in the next years this is going to release. Gen 6 is going to release into full production, and so that's what we're aligning with our customers, and that's the information that we're communicating out to the industry. Some people may be not familiar with all these different acronyms that are in the industry. The SFF 8639 is a form factor standard, and it got a kind of a nickname a while ago as a U.2 connector, and that was the history of that is it that this is a general universal. The U stands for universal, and the dot two is a kind of a carryover from the M.2, and it's just saying in this form factor 8639 there is a universal form that we call U.2, and the evolution of that form is shown on this slide here. And the industry started many years ago with a SATA connector as the I/O interface for hard drives. And as that developed into faster speeds and more pins required, more channels, the SAS connector was created by adding some more pins for that. And then the huge demand of more data, faster. 8639 connector added a lot more pins. It added many other features, hot swapping capability, and backwards compatibility to this form factor. So all the systems, all the chips, all the software that's created for the SAS SATA form factors is getting another breath of life with more capability through the 8639 connector. And you can kind of see that visually here where we've added a lot more contacts, and we are increasing the performance as well. And this form factor gives people a backwards compatibility advantage. So these drives can plug backwards into slower systems, and they're also geared up to move into the future. And that's really what we're talking about here. So maybe to before we can talk about what the future holds, let me just give you a picture of what the last year looked like for the connector industry, and certainly for Amphenol. It was the implementation of the U.2 Gen 5 form factor at this new speed, at a Gen 5 speed of 32 gigabits. So we've released that in these different form factors, and this is just a portfolio starting to get rounded out. Now I'll show you a little bit more graphically what kind of things we offer in terms of changes and hold downs and footprints and variations to it. And so there's many variations. Most of the plug connector, which is we're just talking about here, we'll look at the receptacle, and this is what we currently have in our portfolio, is many different height variations. And you can see on that little picture on the right, the connector in the height gives our customers advantage to move the mating plane or move the things inside their drive around to control that so it fits in their drive form factor, and then it mates into the standard form factor. So this has been implemented for quite some time. We were on the leading edge. We were involved in standards early, which is one of Amphenol's strengths. And so we have Gen 5 plugs that have been released for quite some time. Here's a picture of what those look like. And the reason I like this slide is I want you to see that one of the things that's important, other than just moving the height of the connector, the mating height off of the board, is we offer a lot of different ways to strain relief the connector or hold it down. And then we have a footprint, which is the surface mount attach pads there, as you can see, that solders the connector down. And as I'll explain as we get into the Gen 6 products, it's an advantage to our customer to be able to take what they've done in Gen 5 in terms of laying out their boards and moving into a next generation system. They want to have the least amount of changes possible. So one thing that Amphenol has done really well is make even the footprint compatible. So all these footprints that you see typically move right over into the Gen 6 product. So we keep the footprint the same, we keep the mating interface the same, and what we do is the magic in between those 2 points, and so it's all internal to the connector. And I'll show you a little bit about that when we talk about Gen 6. So this is the Gen 5 plug, and there's also the Gen 6, the Gen 5 receptacle has been released for quite some time. Typically, this comes out in a vertical orientation. It's probably the easiest one for us to produce. It has the best SI performance, and but customers as well then want the flexibility to have it in a right angle orientation so they can have more flexibility with their systems. So we have many different vertical versions, various hold downs, and we've we also have tooled up the right angle version for various customers in our Gen 5. And I'm sure this will be the plan in Gen 6 as well. So that's where we've been for the last year. And now we're looking at and we're working with our customers, and we have tooled up our next generation product. And that's kind of what this webinar is talking about. Where is the future going? And so for the U.2 application, we have tooled up a Gen 6 U.2, and I'm going to show you what that looks like, as well as some of the SI results to get to this new SI speed for Gen 6. But what you can see on this slide is some of the general information and what's in tooled and what's being developed. The important thing is we have many different designs in development, but we've tooled up a plug and a receptacle so we can start getting measured data. And I'm going to show you how our measured data is going to compare to our simulated data for this Gen 6 product line. So this is a summary slide for what we're doing on Gen 6. We see this coming very quickly. This picture is just a little more graphical representation of what I just showed you on the previous slide. We have a vertical versions tooled up with some different heat sink options, not heat sink options, hold down options. And we have all this information available and samples available for our customer. The other thing that is important on this slide, which we see as an application and it's an extension of what's already going on right now in the industry, and that is the implementation of high-speed cables. To get to these higher speeds, the industry is realizing that it's better to go through some type of a higher speed link, and that's through some cable, through a cable. So what the industry is doing is taking these connectors that have an interface for an SSD or mostly an SSD, and putting a cable and directly attaching that cable onto the back of the connector directly to the contacts, so we minimize any loss, and then that cable can run from maybe a bulkhead or even in other locations back through with very little loss to its application point. And so we have many we have some applications like that I want to show you in a little while. This is the graphic representation of what we have available for the plug right now. And you can see that some are in design, some are not tooled, and we definitely have things available for Gen 6. We have parts, and that's what I want to show you what we're looking at. Going back maybe to this the cable application and what do we have available. So on the left hand side you can kind of see one of the designs that would be how you could possibly mount a connector onto a faceplate so that the cable could plug into the back of that, take the information off the SSD back into the system. So you can either do it as a range there, or we offer a version that has a quick release feature so that the implementation is very flexible and very easy to do. And so this is one of the things that we see available. And the reason that I think this is of importance is we're following over kind of on the same design logic as the SSDs. And so the SSD form factor, the EDSFF form factor, has already transitioned to the cable direct attach applications. And so the U.2 is a natural extension to follow on to that. So the same system design can be used for the U.2 application as well. And this has a lot of advantages of reducing space, reducing the loss, and helping to design, especially for airflow, your systems. This slide kind of shows how the quick release attaches, or you could have a panel mounted version. This is the direct attach cable that we have available for Gen 6, U.2. And this slide is just showing the same thing, but here it shows some actual examples that we have. So if our customers are needing samples, we're already supplying samples for this application. And what you see on those samples is the panel mounted version. So let me talk about what kind of performance we get for Gen 6. And because the industry was not sure that U.2 was needed, and it wasn't so confident that we could achieve the Gen 6 speeds. But what I'm here to show you is in the most common application, how we can meet the Gen 6 speeds. And we have parts told, we have SI boards created, and I'm going to show you some SI results. This is a little background for the SI testing, just showing the pairs that we're going to be looking at and the crosstalk associated with those. This will make a little more sense when we get to the next slides. What you're seeing here is an impedance plot of simulation data for the U.2 Gen 6 compared to actual measured data. And what Amphenol is known for, and what we do really well at, is our SI teams, and we build on our SI technology from our back planes right now that are designed to run at 224 gigs, and are the same kind of things that we're using in those applications. We implement that technology into these applications, and so our SI team is really good at their simulation work, and then how does it compare to measurement data? It's usually very, very accurate, and that's what this chart shows. And all these charts will show how did we do in terms of simulated data and measured data. Return loss is always something important, and these charts look great. We're not seeing any concerns even out into the higher frequencies, so we're really happy with turn loss. The insertion loss is looking very clean, way out into well over 25 gigs. Great looking data, and this is a lot of what you don't see that's inside the connector, of how we control the grounds, how we manage crosstalk, and the different type of materials that we use all play into how we achieve these things. The most challenging parts of meeting the Gen 6 for I think all the connectors is controlling the crosstalk. And one of the reasons that is a challenge is, for these connectors, we're constrained by the intermatability specification. So the locations, the positions, the spacing, the locations of the differential pairs, they're all defined and already established. So given that that's fixed, we have to work within that time, within those frameworks, to be able to control the crosstalk. And so if you take our connector apart, you'd see ground bars, a lot of shielding, and many other features. But what it gets us is this level of crosstalk. And the way that we meet the specification is by moving into this exception that's provided through the integrated crosstalk noise strength. So there's a way to measure the amount of signal strength that is at critical frequencies to be able to interpret these things. Because obviously, if you look at this, the spec lines are getting violated. We're on top of the spec lines, but the power at the critical frequency still is acceptable. And that's what this chart shows. That's what we're going to see in the next couple of charts. If you look at just how our simulation data compares to our measurement data, we're still doing a great job. And here's the FEX chart. That looks great. Our customers love seeing this because This is one of the biggest areas, and so we're controlling the far end crosstalk exceptionally well. And just to conclude, so our team is all over the world. We're supplying these products to our main customers, and we're really wanting to give the marketplace some visibility that the U.2 form factor is now released in Gen 6. And so the systems work that I know is going on, the drive side work, people putting this on their SSDs, that's in process. And so we know and are confident that the Gen 6 product is going to roll out in some new form factors, and all that's in the works right now. And so in terms of trends, what do we see for U.2? It's got a future through Gen 6, and we're starting to look at Gen 7 capability as well. So thank you for attending. That is my presentation on the U.2 Gen 6 connector.
Great, thank you, Don. So now we will open for our Q&A portion. So Don, I do already have some questions prepared for you. My first one is the U.2 Gen 6 connector is noted to be backward compatible with Gen 3, Gen 4, and Gen 5 interfaces. Can you please elaborate on how this backward compatibility impacts system integration for existing Gen 5 infrastructure?
Sure. Well, I think why this is valuable to our customers is basically associated with the backwards compatibility. And so you could imagine when you're designing a new system, you have previous generations that you've already tried, you've developed, and you're confident in. So you want to kind of evolve or take another step forward, and many times change as little as possible. And so the backwards compatibility advantage is significant. And there's such a long history of this SAS SATA form factor, starting through HDDs and then moving into the SSDs. And this backward compatibility doesn't apply just to the connectors, but applies to the system works that's done as well. And all the chips, the software, all the development work that's done on the system side and the drive side. So our customers put all this work into it, and they get to leverage that into a new and next generation systems. And the way that we make that possible is making all these changes internal to the connector. So we continue to be very involved in the standards. And right now we're releasing this Gen 6 form factor, just like we've released the EDSF form factors. And we're preparing for Gen 7 as well. We have concepts for Gen 7. We'll continue to stay active in the standards in promoting this. And uh, we're not trying to drive the industry. We're trying to support our customers and what kind of interfaces that they want. And the SATA, or we call this PSAS or U.2, is a historical form factor that has a lot of advantages to move forward. And our customers are saying, yeah, they see that value too, and they're moving forward with it.
Thank you, Donald. And what design or material improvements in Gen 6 help maintain the signal integrity at 64G and PAM4 data rates in comparison to Gen 5?
Well, that is a great question. Um, These are the kind of details, though, that I think we keep very confidential. But I can explain it in principle, and anybody certainly can get a connector and tear it apart and see what we're doing. What we do is builds upon all the other work that we're doing in the industry for backplane connectors and other connectors that require increased performance. So we have intellectual property in absorbing materials, and that helps us with controlling our crosstalk. We have many there's many components actually inside these small connectors, and so we additionally integrate grounding control, or the grounding bars inside of this. as well as this functions as shielding as well. So between shields, grounding, and absorbing crust up kind of energy absorbing materials, we put these things all in the right places where we're trying to achieve these high speed differential signals. And when we put all that together, our SI team works and works and works on simulations, and then our hand in hand with our product engineering uh, design team, they put these two together and come up with our next generation systems, our next generation connectors. And then we typically move that either directly to a customer's, because we have very deep and partnerships with all these customers. We show that to them, and we also begin and showing this and putting it forward in the standards to try and get the standards moving forward. Our customers want to see a standard application, and that gives them confidence in the performance, as well as it gives them advantages for for being able to get materials and connectors.
Thank you. And how do you see U.2 Gen 6 adoption varying between traditional enterprise storage versus AI data center applications?
Um, I think they're going to work together, and I believe everybody understands that the EDSF form factor is the main form factor, and it is dominating the applications, and it is on the cutting edge, and it will continue to be the primary form factor for SSDs or memory inside these drives. But the U.2 form factor is going to be maybe a hybrid version, or some customers may want to run all U.2 because that's how their systems have been built. And we have customers like that. But I think it will turn out to be somewhat of a hybrid application where all these U.2 drives may have cost differences, cost advantages, performance advantages. So a system designer looks at all these options for memory, and it's they're definitely implementing the U.2 with the SAS and SATA functionality for PCIe applications.
Thank you. And what types of system architectures or customer designs would you recommend transitioning to Gen 6 direct attach cabling?
Well, this. I might not have the best answer to this, uh, but our customers, I believe they're wanting to see certain type of performances. And as I mentioned before, the SSD performances are unique in different applications. On the compute side, the highest priorities are performance and capacity, latency. All these factors drive how the speed requirements for these applications. And so the SSDs will continue to be highly leveraged for highest performance on the compute type of applications. And as you move further and further into a data center, there becomes lots of variations of performance required. As you could imagine, not all the data needs to be able to move to be able to be moved around at these high speeds. So these are for the large language models that the requirements are super high. For most of our customers, they don't need the full Gen 6 speeds right away, but they want to design their Gen 5. They've designed their Gen 5 systems with a plan of transitioning into Gen 6. And a lot of it has to do with their existing systems, what their customers want, and certainly the cost of these things. Um, if you're on that cutting edge, you pay for that in many ways. But the U.2 offers maybe a lower implementation cost for our customers who can now use the highest speed applications in this U.2 Gen 6. They also can use slower U.2 performance for other applications that don't require the highest performance.
Thank you. And my final question for you is, how is SSIO ensuring that the U.2 Gen 6 connector and cable solutions align with the evolving PCIe 6.0 and 7.0 specifications and their ecosystem requirements?
Well, my comments, I guess, would be is the reason that the industry has moved so quickly to cables, and certainly high-speed cables, has built on what's going on in the industry. Certainly, there's backplane cables where our customers who have the highest speeds need to pull these signals off of the lossy boards that are in the systems and run them in a flyover type of application. And if you've heard that word flyover or overpass, it literally just means pulling some information and going flying over the board to another drop off location rather than going through the board. And so as that has grown and developed, all these high speed cables are developing our technology for direct attach cables for making these things very fast, is driving at least this one application. So the cables are one part for the super high speed applications that the industry is choosing to use in backplanes and in the storage and server markets as well. There will always continue to be the direct cable, I'm sorry, the direct connector to connector interface. That's traditional. That's where the bulk of these things will be. But for cables, in applications where you demand the highest performance, that's where the cables will be used.
Thank you, Don. I really appreciate you joining us today. And I just want to thank everyone for joining us as well. If you do have any questions about today's presentation, please do not hesitate to reach out. Thank you and have a great day.
Thanks, Greta.